So on Tuesday, we were talking a little bit about specific heat and how to convert with units of energy. Today, we're really going to kind of change it up a little bit, and that we're going to be thinking about the heat associated with chemical reactions. So not physical changes like what we were looking at on Tuesday, but actually chemical reactions. From now on, what you're going to be seeing on paper on some of your assignments are what I like to call thermochemical equations. And what that means is you're going to be seeing a balanced chemical equation followed by the amount of heat either released or absorbed by that chemical reaction. For example, I'm remembering from my previous experiences in chemistry that when glucose C6H12O6 reacts with oxygen and air, producing carbon dioxide and water, I'm remembering that when this reaction takes place, a large amount of energy is released. To the right of the balanced equation, you're going to be seeing a symbol, delta H, followed by a value. And that delta H symbol literally tells you the amount of energy either released or absorbed by the chemical reaction. Now, please know this delta H value is actually something that's called enthalpy or change in enthalpy. Enthalpy is really just another word for heat or energy. There is a very small difference, but for our purposes here in this course, that difference is really irrelevant. So for our purposes, we're just going to think of it as heat or energy. So this delta H value is telling us how much energy is either released or absorbed by that chemical reaction. Now for this particular example that I'm showing you here, again, with the glucose reacting with oxygen gas and air, producing carbon dioxide and water, energy is being released. I know that because of the negative value, the negative number, the negative delta H value. Whenever delta H is negative, that tells you the reaction is exothermic. Energy is being released into the environment. And I would think that you might remember this as a combustion reaction. We talked a little bit about combustion reactions back in first semester chemistry. Combustion reaction, combustion is another word for burning. So of course, burning is going to release energy into the environment. So delta H will always be negative for an exothermic reaction. The products are literally giving off energy into the environment. If you see a thermochemical equation, which again just means a balanced equation, which also includes a delta H value, if you see a delta H value that is positive, that tells you the reaction is endothermic. That literally means as the products are forming, they're taking energy into their bonds. Energy is going into those new chemicals that are forming. If you were holding a test tube or a beaker, you would feel the test tube or beaker getting colder. Very important for you to remember here in this unit that if delta H is negative, that means you have an exothermic reaction. If delta H is positive, that tells you you have an endothermic reaction. Now, let's take a look at your practice problems page, and I will show you an example here really quick. This worksheet is titled Enthalpy Stoich. Remember, enthalpy is just another word for heat or energy, just a fancy way of saying heat or energy. And I like to call this Enthalpy Stoich because you're going to be doing just a little bit of stoichiometry, but also incorporating that enthalpy value. If you look at number 1 on your practice problems page, it says how much heat will be released when 6.44 grams of sulfur reacts with excess oxygen according to the following equation. And they give you the equation. Remember, I'm calling this a thermochemical equation because not only do they give us the balanced equation, but it also includes off to the right the delta H value. In this case, with number 1 on your practice problems, notice there is a negative delta H value. That also tells me that the reaction is exothermic. So what they're asking us here is specifically how much energy would be released if we specifically started with 6.44 grams of sulfur. We can see from the thermochemical equation that whenever this reaction occurs, 791.4 kilojoules of energy are released, but they're asking us a more specific question about that. What if we specifically started with 6.44 grams of sulfur? Based on that amount of sulfur, how much energy would be released? So this is where the stoichiometry is going to come into play. I'm going to take the 6.44 grams of sulfur, write that down and put it over 1. This is exactly the same way we would start any stoichiometry problem. Multiplication symbol and then draw a line. And just like we would do for any stoichiometry problem we've done the entire semester, we need to convert grams of sulfur to moles by using the molar mass of the sulfur. When you hear me say molar mass, you should be thinking, okay, that means mass from the periodic table, the mass of sulfur from the periodic table. And you know, typically at this point when we do stoichiometry, we would set up our mole to mole ratio. But in this case, because they've asked us for heat, how much heat is released when we start with 6.44 grams of sulfur, we're going to set up a heat per mole ratio from the thermochemical equation. I'm using the negative delta H value on the top. On the bottom, I'm using the coefficient in front of the sulfur. According to the balanced equation, there are 2 moles of sulfur reacting. And then that's it. All we have to do is multiply straight across the top and divide by any numbers on the bottom. In my calculator, I would type 6.44 times the negative 791.4 divided by 32.06 divided by 2. Remember, you can press the divided by button twice on your calculator. Yes, you divide by any numbers on the bottom, and you should get about negative 79.5. I think maybe 1 or 2 decimal places would be reasonable for these answers. Fortunately for us, every one of these enthalpy stoichiometry problems follows the same format. So really, once you've seen one of them, you've seen them all. Reach out to me if you have any questions at all about how to do these enthalpy stoichiometry problems. I hope this makes sense. I hope this seems pretty straightforward. Again, you want to be able to tell the difference between endothermic and exothermic reactions. If delta H is negative, that tells you you have exothermic. The products are giving off energy, releasing energy into the environment. If you have a positive delta H value or a positive enthalpy value, that tells you that energy is being absorbed as the products are forming. Don't forget to submit your practice problems, and hope that you enjoy the rest of your day.